Have you ever wondered how sodium hydroxide crystals are prepared by electrolysis? Sodium hydroxide, commonly known as lye or caustic soda, is a chemical compound with a myriad of uses. From soap making to food processing, and even in the realm of biodiesel production, sodium hydroxide proves itself to be versatile. But what makes sodium hydroxide truly fascinating is its preparation, especially through a process called electrolysis. Electrolysis is a method that uses an electric current to drive a non-spontaneous chemical reaction. In this case, we use it to transform humble table salt and water into sodium hydroxide crystals, a procedure that's as intriguing as it is efficient. By the end of this journey, you'll have a comprehensive understanding of how this process works, the science behind it, and the step-by-step procedure involved. So, are you ready to learn the step-by-step process of preparing sodium hydroxide crystals? Let's dive in. Before we get started, we need to prepare our tools and materials. First up, we have table salt, which is also known as sodium chloride. We'll need this to create our brine solution for electrolysis. Next, distilled water, which will act as our solvent. It's crucial to use distilled water to ensure purity and avoid unwanted chemical reactions. We're also going to need 2 graphite electrodes. These will carry the electric current through our solution, and graphite is a preferred choice due to its non-reactivity. To power our electrodes, we'll need a power source, like a battery. Our electrolysis will take place in a non-metallic container, also known as an electrolysis cell. This should be clean and free of any contaminants. And last, but certainly not least, safety first. Always remember to have protective gloves and safety glasses on hand. Now that we have all our materials ready, we can move on to the actual process. Now, it's time to get our hands dirty and start the experiment. Our first step is to prepare the electrolysis cell. This involves filling a non-metallic container with distilled water. It's crucial to ensure that the cell is clean and devoid of any impurities or contaminants. Distilled water is preferred because it ensures the absence of impurities and other minerals that may interfere with the electrolysis process. Next, we dissolve table salt, also known as sodium chloride, in the distilled water. Gently stir until the salt is completely dissolved. The concentration of this brine can vary, but a concentration of around 20% weight per volume is generally recommended for the best yield. Once our brine is prepared, we connect 2 graphite electrodes to the positive and negative terminals of our power supply or battery. Graphite electrodes are recommended due to their non-reactivity and ability to withstand electrolysis conditions. Other types of electrodes, such as metallic ones, may introduce impurities or react with the electrolyte, affecting the quality of the sodium hydroxide crystals produced. With our electrodes connected, we carefully place them into the solution in the electrolysis cell. It's important to ensure they are spaced apart and not touching each other. This is where the real fun begins. We then turn on the power supply, creating a direct current through the electrodes. The positive electrode is known as the anode, and the negative one is the cathode. As we switch on the power and the electric current passes through the brine, electrolysis starts to occur. At the anode, the chloride ions in the brine undergo oxidation, releasing chlorine gas and electrons. Meanwhile, at the cathode, water molecules undergo reduction, resulting in hydroxide ions and hydrogen gas as byproducts. The hydroxide ions formed at the cathode combine with the remaining sodium ions from the brine to produce sodium hydroxide. As the electrolysis process begins, the real magic starts to happen. With the electrolysis process underway, the formation of sodium hydroxide crystals is just moments away. As the direct current flows through the brine, a fascinating chemical transformation takes place. At the anode, the chloride ions from the brine undergo oxidation, releasing chlorine gas and electrons. On the other end, at the cathode, water molecules get reduced, producing hydroxide ions and hydrogen gas as byproducts. These hydroxide ions then combine with the remaining sodium ions in the brine, resulting in the formation of sodium hydroxide. This reaction forms a white precipitate or crystalline formation that begins to accumulate near the cathode. It's a sight to behold, science in action, but remember, patience is key. Allow the process to continue for about 30 minutes to an hour to obtain a substantial amount of sodium hydroxide crystals. Once the time has passed, it's time to carefully remove the electrodes from the solution. Remember, safety first. Turn off the power supply and set it aside. Now it's time to collect the fruits of your labor. The white sodium hydroxide crystals that have formed near the cathode are ready for collection. You can scrape them off with a plastic spoon or use the filtration method. It's important to rinse the crystals with distilled water to remove any residual impurities. Finally, store your sodium hydroxide crystals in a desiccator or an airtight container. This step is crucial as it prevents moisture absorption, which can affect the quality and storage life of your crystals. And just like that, you have conducted a successful experiment in the comfort of your own lab. You've seen firsthand the power of electrolysis, transforming simple table salt and water into sodium hydroxide crystals. It's a testament to the marvels of chemistry and the endless possibilities it offers. And voila, you have just prepared sodium hydroxide crystals by electrolysis. So there you have it. You now know how to prepare sodium hydroxide crystals by electrolysis. Let's recap the key steps and points. You begin by preparing an electrolysis cell, dissolving table salt in distilled water, and setting up a direct current through graphite electrodes. As the current passes through the brine, electrolysis occurs, producing sodium hydroxide near the cathode. Remember, it's crucial to use distilled water, void of impurities that could interfere with the process. The choice of electrode material is also vital. Graphite, due to its non-reactivity and durability under electrolysis conditions, is the preferred option. And let's not overlook temperature control. While high temperatures can speed up the process, they might also cause water evaporation. Therefore, a stable room temperature is recommended. Most importantly, never neglect safety. Wear protective gloves and safety glasses to prevent contact with the solution and potential splashes. Remember, safety first and happy experimenting.